In this video, we're going to talk about Chapter 8, Arrays. Here's the chapter topics. You can read over them when you're reading the chapter. An array allows you to store a group of items of the same data type together in memory. This allows you to create an array in memory instead of having to create a separate variable for multiple employees. Instead of creating multiple similar variables such as employee 1, employee 2, employee 3, and so on, an array is a more efficient way. It allows you to just create one variable, and inside of it, it has different elements. Here's the declaration for an array. It's going to declare string employees, and the 50 in the brackets means the size of 50 of them. So you can put 50 employees in there. Declare real sales amount. You have 7 different sales amounts. The storage locations in an array are called elements. Each element of an array has a unique number called a subscript that identifies it. In most languages, it starts at 0. Here's an example of what memory will look like. You have a constant for integer size equals 5. And then on your declare statement, instead of putting 5, you're putting in the variable. The reason you do this constant is because if later on they want you to change it to 15, you just go to the variable and change the 5 to 15. And every time you reference size, it's going to do 15 instead of 5. The first element is going to be at 0. The second element at 1, 2, and so on, all the way up to ever how many elements. Notice there's not an element 5. The reason being is it starts at 0. So if you're trying to index an array with an index of 5, it's going to give you an error because there's not an element 5. That would be the 6th element. Here's a way to assign values individually. You use the set numbers, and in bracket you put 0 equals 20. So the first element is going to be 20, the second element 30, the third element 40, the fourth element 50, and the fifth element 60. But it is more efficient just to use a loop to step through the array. Here's another example. This is the hours array. You have a 40, a 20, and a 15. Arrays can be initialized to 0 or a specific value. Declare string days, and then 7 means there's 7 days in the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Array bounds checking. This is what I was talking about earlier. If you have the size of 7, the highest index you can put in there is 6 because of 0. So when you index 7, it tells you invalid. This is common error. Partially filled arrays. There's sometimes an array are only partially filled. To avoid processing the unfilled elements, you must have an accompanying integer variable that holds the number of items stored in the array. When the array is empty, 0 is stored in its variable. The variable is incremented each time an item is added to the array. The variable's value is used as an array size when stepping through the array. Here's the example. This is what they're using as the counter, equals 0, and then they have an index. They're going to enter a number or -1 to quit, while numbers not equal to -1 and counts less than size. What that's going to do is if the 5th number I enter in, if I put in -1, it's going to quit processing the rest of the array size all the way to 100. So it's going to save you like 95 processes. And they're setting the values, which is the array name, to whatever the counter is equals number. So the user inputs the number up here on this input number statement. Inside the while loop, they're going to move the number to the element in the values array that's represented by the variable count. And then they're going to add 1 to the count to go to the next element, have them enter the number again or -1 to quit, and then another input number. Once it processes all 100 elements or they enter a -1, it's going to go down here and display all the values that was entered. Notice they're using a for loop on this. Remember, the for loop is good to use when you know how many times you need to process the loop. And in this case, we know we need to process it 100 times because of the size up here. And that's why on the for loop, they say index equals 0 to count -1. That means from 0 to 99. If you don't put the count -1, you're going to get an out of bounds error because it's going to try to use the index 100, which would be element 101, which it doesn't exist. And then they're displaying whatever element the index is in the array. You can also use a for each loop. Not all languages provide this, but most do. It works with an array, iterating once for each element. During each iteration, the loop copies an element's value to the variable. Look how much simple this is. For each num in numbers, display num. Num is the integer that they're using to increment, and numbers is the array. So how do I know if it's array? If you have a variable with the brackets, that's telling it's an array. A sequential search algorithm is a simple technique for finding an item in a string or a numeric array. It uses a loop to sequentially step through an array, compares each element with the value being searched for, stops when the value is found or the end of the array is hit. They set this variable to false set an index to 0. While found equals false and index is less than or equal to size, then they're going to compare the element in the array to whatever the search value was that was entered somewhere above this. If it's found, they're going to make the variable found equals true, else they're going to add one to the index. So if it's found, when it goes this indef and comes back here to the while, it's going to be true, so it's going to go on down to the end while. If it's not found, it's still going to be false, and then it's going to add one to the index. As long as it just hasn't processed the last element of the array, it's going to continue in that loop. Totaling the values in an array and calculating the average. Loops are used to accumulate the values. Then the total is simply divided by the size. Here's an example. You have a constant integer named size, so it tells you the size of the array is going to be 5. You declare the array right here. They're going ahead to initialize it with these 5 values. So in memory, you'd see the array with 5 different elements. The first element would have the 2.5, the second element 8.3, and so on. Then they're initializing the accumulator variable. And then they declare the average variable. Then they declare the index variable. And then they're doing a for loop. For index equals 0, that's to tell it to start at the first element to size minus 1. So it's going to start the first element, go all the way to the end, and then they're just accumulating. Same way you have been doing accumulators all throughout this book. You take the accumulator, which is total, and say equal to the same accumulator plus the element in the array. After it goes through all the elements in the array, then it's going to get the average on line 22. Line 25 is going to display it. Finding the highest and lowest values in an array. On the highest, you create a variable to hold the highest value. You assign the value at the element 0 to the highest variable. Use a loop to step through each of the rest of the elements. Each iteration, a comparison is made to the highest variable. If the element is greater than the highest value, that value is then assigned to the highest variable. You do the same process for the lowest, but check if the element is less than the lowest value. Copying an array can be done using loops. You use the for loop, then you take the second array and copy the first array to it. Passing the array as the argument. Usually you must pass the array and the size. This is the call statement. That's the arrays named numbers, and that's the size. In the module header, remember you have to put the data types here, and they put the brackets on this array here. Notice you didn't put the brackets when you passed it. The computer's smart enough to realize it's an array. Parallel arrays. By using the same scrub script, you can establish a relationship between data stored in 2 or more arrays. In this example, they have 2 arrays, the names array and the addresses array. The name and the address must be the name and the address for the same person. So like person 1, you put their name and address. Person 2, their name and address, and so on. You can have 2-dimensional arrays, which are like several identical arrays put together. The example they use here is a teacher has 6 students who take 5 tests. He's got columns 0 and 0 right here. That would be the first student and the first test. You go across the top row, that'd be the first student in the second test, and so on. Then you get to the second student, you drop back down to the column 0. And this is how you process that. You have 2 size variables are required, so they have a constant called rows and a constant called columns. So there's 3 rows and 4 columns. And then you declare your array, and you put the rows first and then the columns last. Accessing is done with 2 loops. For row equals 0 to rows minus 1. For columns equals 0 to columns minus 1. And so that's how you enter in the number for that. So when the user enters in a number, the first number they enter in is going to go to the element 0, 0, which is the first row, first column. You also can have 3 or more dimensions. Now let's look at the lab sheet. Just make sure you read all this, and then you just fill out the rest of this information. Read it carefully, because some of you turn in these lab sheets, and I can tell you're not reading what it tells you to do because they're not even close. So it tells you an array named pints of the data type real, the size of 7. That's what you have to declare down here. So you'd go down here and you say declare pints, bracket, 7, close bracket. And then you just go down here and declare it. Then you scroll down and you read it and do it. So you keep on going. There's examples in the book on some of this stuff, but you just make sure you fill all this out. Look right here. This is one of the slides we had in the PowerPoint. It's talking about doing high points and low points. Go back and refer in the book, and it tells you what page and all. So make sure you look back if you're having trouble with it. The way you do this, you complete step 3 based on step 1 and 2. You go to step 2 and go through this code to see what you put in step 3. So they set total to points to equal 0, and they do the counter. It says for counter equals 0 to 6. So in 0 is 34 because that's the first element. The second element is 39, so they added 39 to 74. The third element, would have 2 in there, they would add 25 to the 73 and just step on down through that. You do the same right here with step 4, step 5. They go together. Set high pints equals pint 0. That's where this 34 comes in right down here on high pints. Then when you go on, it says for index 1, well, index 1 is 39, so that's where the 39 comes in. And then you process on through. If pints index is greater than high pints, then set high pints to pints. It is greater, so you'd move 39 to high pints, but then when you process through, you're on the second element, which is 25. So is 25 higher than 39? No, it's false out here. So you step through that, and you go to here and do the low, and you step through that. Then he says, design a program that asks the user to enter the store sales for each day of the week. The amount should be stored in an array. Use a loop to calculate the total arrays for the week and display the result. Make sure you use arrays. Don't use a bunch of variables. I'll still have students that will turn this in using variables. I'm going to give you a 0 and make you redo it. Make sure when you're getting the input that you tell the user what day they're entering sales for. There's examples throughout the book on this, and most of you have been doing this, but some of you aren't. When you get done, you zip up this lab sheet and the Chapter 8 Lab 1 and name it last name CH8. If you don't name it that, that's 5 points off. If you don't name your program CH8 Lab 1, that's 5 points off. And submit that one compressed zip folder on Blackboard. I hope this video helped.